Good, we are live. So hello everyone. This is Postgres TV episode 2, the first season, and I'm Nick, and together with me my co-host Ilya. Hi Ilya.
Hi everyone. Hi Nick.
So we have a very interesting guest today, Peter Geoghegan. The first question: am I right with pronunciation? Geoghegan?
Yes, you are. Yes, you are.
Cool.
I know that I made it when people started pronouncing my surname correctly.
Right. So actually, we in our Russian show we discussed it many times, like how to pronounce your name, because you mentioned in the release notes many times. So we discussed your contribution, and we have like question how to pronounce, and we decided to invite you just to figure it out. So
yes, it's actually just a matter of ignoring the spelling, which is very counterintuitive, and it's just Geoghegan. What I used to say to people is it rhymes with Ronald Reagan. I guess I stopped saying that at some point, but that is sort of a helpful mnemonic.
Right. Okay. So
who cares?
Right. Before we start asking questions and discuss interesting things about Postgres, I want to to say a few words about this show and our idea. So the idea is that this year is different from others, and meetups and conferences are offline events are like there are almost no offline events. But not only because of this we decided to start it. Also, we feel like many people are distributed right now. So we like, especially for Russian community, it's very obvious that we're like all over the globe. And the idea is to be able to discuss interesting questions about Postgres with interesting people, guests, and everyone should be able to ask questions anytime. So we will have some experiments with format. We don't have any strict rules. It's not a formal conference talk.
So we basically try to introduce virtual old Dubliner from PGCon to the internet. So basically, it's the idea anyone can show up and talk about Postgres.
Right. So maybe right. And I'm going to post our Zoom link. If you're watching right now on YouTube, you can ask questions in chat. We will monitor it and use your questions to ask here. But also, if you want, you can join our Zoom call directly and just talk to us and ask questions right by voice. And feel free to do it. And also, I will post another comment to our document where we collect ideas. For this episode, ideas are already collected. We have the plan how to.
We had too many ideas for Peter.
Yeah, actually, for 1 hour we will have too many ideas. But for future, you will be able to go to that document and also see what is planned and also propose some idea. So that's actually it about the format. Let's start talking about you, Peter, and Postgres. First question is how it all started, and do you remember why you chose Postgres and start working with it?
I do. So the story starts with me. I was working for a not terribly interesting business, kind of a startup that was doing point of sale business information system stuff, and we were using Postgres, and this was approximately 2007 to 2010, and I realized that no one had heard of it at the time, and yet it seemed to be exceptionally good. So, and also sort of developed an affection for it, the design principles behind it and stuff like that pretty quickly. So I thought, well, there's something to this, isn't there? I think it's good to be part of something before everyone appreciates that it has real, potential. So that was kind of the initial germ. Subsequent to that, I was going to conferences. I went to Paris in 2009. At the time, I still lived in Europe. I'm from Dublin, Ireland originally. And so I met people at the conferences, and that seemed to go pretty well. There was a lot of interesting people with interesting perspectives at these events. And then around late 2010, which coincided with the Stuttgart conference, I was hired by Second Quadrant. And then at that point, I pretty much started working on Postgres, not initially submitting some small patches here and there. But then that's
actually interesting how you started with this, because for many people, I'm sure it's like a very important part. How you can start with Postgres.
Like barrier is very high, right? To start talking to hackers.
Yeah. So I suppose that I had the benefit of when I was working at Second Quadrant. Naturally, I got advice about direction informally, and there's a lot of places you could do that now, but for me at that time, that was how I did it. So it wasn't like anyone was really telling me what to do, but just by being in that environment, I soaked up by osmosis, always do this and never do that sort of principles, which are kind of a necessary part of participating in the community. But also, I think more than that, it might have just been a lack of self-awareness. Like, don't think about it, just do it, was sort of my philosophy then. I think it's quite possible to think of many reasons to not pursue something like that, but I was fairly single-minded about it for whatever reason, and I think that probably was a significant factor as well. So anyway, it was a time in my life where I was, super earnest and ambitious, honestly, and like really earnest, disgustingly earnest, and that kind of hurt. So subsequently I moved on. I actually moved country twice since then. I moved to Canada for almost 2 years. I was in Vancouver, and now I'm in San Francisco. So I worked for Heroku Salesforce for almost 4 years then, and that gave me, I think, a very different perspective, having sort of gotten the Orthodox community perspective. At Heroku, I think, apart from making a lot of good friends, I also got the on the ground floor experience about how ordinary app developers, people that are working on Django, people that are working on Ruby on Rails, how they thought about things. And that did clarify a few things for me. I did, around this time, do a little work on JSON-B. I helped out with the initial commit there, probably owing to that being a real priority for Heroku at the time. And then I did UPSERT as well, which is a very difficult project. And that took me more than 2 years of pretty solid work. And I was lucky enough to have that supported at Heroku. And then 2017, I went to VMware. I sort of did working at a big software company thing for a little while. And now at the moment, I'm at Crunchy Data, and I pretty much, not even pretty much, I simply work on Postgres full time. They're very supportive of my work. So I really enjoy that. They take a very hands-off approach, which I appreciate.
So yeah, I remember how I met you in person. It was San Francisco meetup organized by Josh Berkus. I just checked; it was 2014 in summer, and I remember you talking about JSON-B, and I was thinking, interesting. So I know that Oleg Bartonov and his team was working on this on the same. So you also was involved, right?
Right. Well, I was involved with that, but that was kind of a once-off thing. I was involved for about 3 months with that. Towards the end, people that were working on it on the main effort were sort of, I guess they were getting tired because it was pretty intense, and I sort of helped a little bit towards the end. And I remember I remember that being a big priority for Roku, which is why I mention it.
So it was started like a sort of review of the thing that people did, or you had just some ideas and come up with them?
Well, I think probably my most important contribution to that project was, so I was the one that ended up saying we should cut scope here, here, but not here and here. And no one was willing to do that. So I was kind of the asshole that that did that. And I think that was a helpful contribution for me to make. There was disagreement as to where to draw the line because it was a very large patch, as you can imagine, and it was getting quite late in the cycle at that point. And there was two groups of people, people that were working on it and were really close to it, and other people that kind of didn't really know anything about it and didn't even know what one might want in a document database. So I kind of I played the role of being somewhere in the middle of those two, which I think smoothed things over.
Right, but
anyway,
in the end of this, I think right now, looking at the past, we see that this is a huge improvement for Postgres. I mean, JSON-B,
yep.
in gene indexes for it, it's huge. So
yep.
it's
I don't deserve very much credit for that, but I thought I would mention it, as I say, in the spirit of what each of these companies may have meant.
Right.
So it looks like today everybody is expert on epidemiology, and it looks like you got the idea of working with indexes through JSON-B from Oleg at some point. So it was like,
yeah, we wanted to discuss
sort of disease.
how you moved from various topics like
UPSERT,
like UPSERT and JSON-B, how you moved to indexes, because it's obvious right now that latest years you spend mostly on indexes and various kinds.
Yeah,
But before we discuss this, like to finish with companies, I wanted to raise a question. How does it feel to work with Postgres only company like Second Quadrant or Crunchy compared to a bigger company which has other priorities, like bigger scope of work, like VMware or Salesforce as well?
For me, it wasn't so different because I was always quite sure of what I wanted to do, which is perhaps not always easy, but I was quite set in my ways. So I knew that was what I was going to do, and I was quite clear about that. And for that reason, perhaps they wouldn't have given me a job if they weren't willing
like
to.
100% Postgres, 100% of time Postgres.
Not 100% for the most part. I am at 100% now since joining Crunchy. That is the deal we have, and that's great. I think it was more like 70-80% for most of these other places. Second Quadrant, of course, I was just starting out, so it wasn't that high. Yeah, I mean, I guess that I was able to make the argument internally about where value could be attained, and that mostly worked out fine. And my experience with large companies is that their priorities are always in flux, and if you wait to be the priority, you'll have to wait forever, because it's really unclear to everyone what the priorities are.
Right. So for example, for a person who wants to work on Postgres only, what is your advice to seek a job in? I mean, to seek a job only in Postgres only company, or large companies with big Postgres activities also.
I think you can do either one. I would suggest that if you're starting or kind of in the maybe not all that experience, it might be better off with a Postgres only company, because then you have that feedback, which you are less likely to get at a big corporation, maybe much less likely. But for me, I didn't experience that much difference on average, or if there were differences, they were based on accidental circumstances that didn't really have anything to do with the larger organization. So I would just say, find a company that seems to have the right general attitude, and maybe negotiate on that basis, that you want to do a certain amount. And I think you'd be surprised at how open many companies are to this these days. It really isn't that uncommon if a person has somewhat of a track record, not necessarily a big one, but if you have somewhat of a track record, I think you might be surprised how doors open.
Is it a good idea to take a look how attitude towards the community from the side of the company looks like? So if the company declares it's community oriented, does it help actually to build this proper interaction between 100% Postgres developer and company?
Well, I don't usually so much listen to what big companies say as pay attention to what they do. That is, of course,
that's a good point.
That is, of course, what matters in the end. I don't know that it necessarily matters what the intrinsic motivations are, whether there's some big picture where they want close cooperation broadly, or maybe they've got very narrow goals. It doesn't necessarily matter. All that matters, I suppose, is that it's consistent with what you want to do, and it's pretty likely to stay that way. That would be my opinion of that question. It doesn't necessarily matter why people do what they do in open source. It can, but it may not. So hard to say.
It makes sense. Okay, let's talk about how you moved from various topics, like, of course, as I said, like JSONB and UPSERT, like big contributions, and how you moved to index. Like your recent contributions are like huge. We created in our document, we created a log of your recent contributions. Not all of them, like some were omitted, but most of them look like you're mostly interested in indexes, like performance.
Or maybe it looks like you just touched some part of the index and then it like started to go one after another.
To fix one problem and then you see another problem and so on, like a chain, right?
It's kind of both. So first of all, I was thinking about indexes, and in particular the standard btree index access method code, for a long time before I really did anything. Although I suppose you could say the amcheck module, which is a tool for detecting index corruption, was a relatively early example of my working on indexing. So whether or not you count that, if you don't count that, then I was thinking about it for a very long time before I did anything. And you're right then that there was this tendency for me to, I don't want to call it serendipity because that discounts how it's important to, it's not just luck. It's important to be in the right place at the right time, and then you are open to getting lucky, if you will. I would point out, for example, that the original intention, the primary goal of my work in Postgres 12 to improve indexing originally was to support something called retail index tuple deletion, which is where if you have a system where you have rollback segments and stuff like that, generally speaking, you have to delete entries in an index at the point where a transaction that deletes them, say, commits, and no one can see those anymore after. So the thought originally was, we're probably going to do that at some point. So that would be the main reason to do this. But as it turns out, that hasn't happened and may never happen. But that didn't really matter because I also had like 5 other reasons for doing it. And the other ones worked out. So I had, it had that property going into it, and that's something that I always try to do. Have a bunch of reasons for doing something so you can afford to be wrong about at least 1 or 2 of them is, I think, a good idea. And Another observation I would make is you can look at my work on Postgres 12, which is where I did a number of things actually, but people tend to sort of think of it as one big thing. There was only one or two big commits, but each of those things could be seen in isolation, and traditionally perhaps would be considered each on its merits alone. But in fact, the real value of these things is only apparent when you use them all together. So they really are worth much more than the sum of their parts. And a person could very easily miss that point, and it is an important point. I've heard other people, I'm thinking of Andres Freund, observe a similar thing in a completely different area, where you have these 3 or 4 different optimizations that each on its own is mediocre. But if you put them all together, it makes a huge difference. And that seems to happen from time to time. That's another point I would make about it.
And we're talking about the default choice for indexing btree, so it affects positively a lot of setups, right? So even small improvement is very important.
Right. Sorry, go on.
I just wondering how easy it is actually for you to keep in mind this entire picture. Basically, if you are developing Postgres, not just using that like DBA, for example, it's difficult to grasp this. How you do this? How you see those opportunities to collect some optimizations together and bring such interesting things?
That's a good question. I think what I try to do is know a little bit about everything. And that's maybe sounds absurd, because here I am, some kind of super specialized indexing person saying, you know, I try to take a general perspective on things. It may be better to say within indexing, there are actually quite a lot of perspectives you could have on it. You could have a data structures perspective, you could have an algorithms perspective, you can have a concurrency control perspective, you could have the perspective of an ordinary user. There is not just one dimension of optimization, that is throughput. There's latency, and there's also total cost of ownership, which I think is going to become much more important in the future. If you can be someone that kind of gets all of these things at the same time, at least somewhat, I think there's a good opportunity to realize what each of these different groups may not have been able to see on their own. That's something I think is helpful for me.
What do you mean by total cost of ownership? Like index maintenance or what?
Index maintenance. Well, first of all, running the thing in production, making it convenient for the DBAs is basically a cost imposed on people using Postgres. If it's just difficult to run, that is a big cost. If it's unpredictable, that's a big cost. If you have what's sometimes called write amplification, that's a big cost, which may not be experienced by having the throughput of your app or even the latency go down. But in an era where you have these wonderful flash memory devices, NVMe SSDs and stuff like that, if you can reduce write amplification, that could be very valuable.
It's always sort of trade-off. Maybe the size of the indexes per se, it's not that expensive from this perspective.
Right. So, for example, if you consider index deduplication, which was in Postgres 13, and which was something that Anastasia Lubanakova and myself worked on. So obviously that's making the indexes smaller. Everyone can see that, that's pretty simple. But my observation is that in real data, there tends to be, skew is very common. You can have power law distributions and stuff like that. So you don't really think that you have low cardinality data, but you do. To give an extreme example, imagine an index that has half of the entries are completely unique and the other half are all nulls. That's very common. It would be nice if we could sort of for free not have to store I mean, we're obligated to store the nulls. That's just, those are the semantics. We know people maybe don't want to store the nulls, but do anyway because they're just not aware. It would be nice if we just didn't have to use very much disk space for those kinds of things where you have a huge amount of redundancy. So people don't even know that that's happening. It's more, I mean, it could be as an extreme an example as that, or it could be more often a natural kind of a skew where much of the index maybe isn't useful, but you don't even realize that because it just doesn't appear to be that way to the app developer. So I think there are dynamics like that that do come up very, very frequently. So you don't have to have low cardinality data to have a low cardinality data problem, if you will.
I'm actually afraid that such improvements in Postgres actually attracting people who do not like to think a lot. So you bring the functionality which allows programmers not to think about cardinality, not to think of effective schema design. Probably.
Right. Remember, we discussed it was on Russian in our Russian stream. We discussed that this cascaded sorting may increase number of cases when people just have single column index on each column. So you have a right amplification, and it's because queries work fine in the beginning, but then it hits you from another side. So maybe like if you optimize some area, maybe it can be bad from different perspective. Did you see patients or not?
Yeah, I mean, I personally believe that many applications don't use any kind of normalization very consistently. And so, for example, we'll use text columns as an enum-like column, and they will benefit extraordinarily well from the duplication stuff. But in my perspective is they're going to do it anyway. So, I mean, it may not matter in the end. I think to some degree, the responsibility of a database is to be robust against things that are silly, that are maybe not particularly well thought out. It's going to happen, and even if someone is very prudent about this stuff, you can always get unlucky, and so I try not to worry about that too much, basically.
Okay, and it looks like right now, if you are choosing Postgres version, you expect a lot of transactions happening, especially if you expect a lot of changes like deletion or updates. Postgres 13 is very promising, right? Because of deduplication, and also in Postgres 12 there are some improvements to make index smaller and suffer less from bloat, right?
Yeah, so Postgres 12, in some sense, maybe helped deduplication because it originally made the page split logic, the logic that we use for choosing where to. So in general, in a btree index, the way that you expand the index when you add new data is when you fill a page, an 8K page, to the point where the incoming item won't fit anymore, you have to split the page. So originally there's a range of values that the page represents, part of the key space, we sometimes say, and anything in that range of values is supposed to go on that page. So a page split splits that in two. So you've usually cut the range of values roughly in the middle, and you distribute each half to new pages. So the really kind of tricky part, complicated part of the Postgres 12 work, which was something I did with a little help from Geoghegan and Kangas, was to handle duplicates intelligently, and that involved enhancing the page split point choice logic. So that was probably the most complicated part, but actually it was definitely the most complicated part. So that kind of made it more adaptive, I would say, where it can, it isn't intelligent, but it appears to be intelligent by adapting to it sort of evolves to accommodate low cardinality data, and that was something that helped the deduplication project by having. So let's say you've got a large group of duplicates, like say you've got a few hundred that maybe will only fit on one page. It would sort of make it so that those all go on their own page together, and things like that. So and then if you're doing an index scan, you're descending, you don't have to visit 2 leaf pages, even though you maybe have hundreds of dupes, because the page split logic intelligently located those on their own page. And then following that, the duplication logic could kick in into Postgres 13, because that works by not changing anything until the point that it appears you have to split the page. It then merges together the original index tuples, which have the same old representation. Now you can create a new representation that's logically equivalent, but much smaller. So it's like it's kind of an organic process, I would almost say, where it sort of automatically adjusts to different cardinalities in a sort of bottom-up way, which I tend to think of as being like that's kind of that's like how B-trees are supposed to work anyway in general. So it's almost like it's looking at the original thesis of how B-trees work from first principles, and it's saying, okay, well, how could we enhance that? Not by adding something new so much as complementing what's already there, making it more robust, more stable. If that makes sense, maybe that's too abstract, but that's kind of how I think of it.
So in the other words, it looks like this is the same step like optimizer made from rule-based to cost-based. So basically now you don't need to think about cardinality. You can actually your database make it for you just by design of a data structure. So right?
Mm-hmm. I'm sorry, I didn't hear what you said because the audio was choppy. Could you repeat, please?
Sorry. Yeah. At some point, optimizers may make a huge step from rule-based to cost-based. So basically, instead of saying do this and do that, we now can just relax, and database with its statistics and optimizer can do everything for us. So basically, it's the same huge step forward. So basically, now you do not need to think about cardinality. You just can rely on clever data structure within database, and everything happens on itself.
Yeah, it's a little different to that, I would say, in that I see the connection you're making, but the difference here is we're delaying making a decision until as late as possible, in order that when we have to make a decision, it's the best decision and a decision that's locally optimal, because B-trees are maintained recursively. So you're splitting at the lowest level. And then if you can delay, then when you have to split the page, you can probably make a better decision about how to do that. That's going to be more robust.
Because you know your schema better, not schema, how actually the data is stored.
Yeah. So it's not, it appears to act intelligently, but isn't in fact. I would describe it along those lines at a high level, because it's almost evolving to accommodate the data as it occurs, and that seems to be a very effective way of thinking about it. And I think there'll be more of that kind of thing in the next release. More things based on that sort of high-level intuition from me.
Interesting. Can we actually expect that at some point this low-level optimization would be so efficient that we will store data in Postgres so properly that we do not need auto vacuum or vacuum in future? Or
it works maybe so like so well that we don't suffer anymore, like we suffer in prior 13, prior 12. We need to do like not only auto vacuum. It's obvious that index maintenance, that means that we need to rebuild indexes from time to time, because they not only have bloat, but they grow in the case of a lot of updates, and auto vacuum doesn't help to make them to make them smaller again. So
right.
reindexing.
I mean, of course, it's true that if you don't change any indexed columns, then you'll usually be able to apply the hot optimization, which is one way that this problem could be totally avoided. But of course, that isn't always possible for many reasons. So my general high-level thought on vacuum is, okay, so I don't even, when people talk about vacuum, what they tend to really mean is the way that MVCC works in Postgres, which is a very close thing, but not exactly the same thing. There's no reason why in my opinion, many of the current bad consequences of vacuum are not inherent to the design of MVCC in Postgres, but are rather things that simply haven't been sufficiently well optimized yet. It isn't necessarily a problem that vacuum has to run and scan the whole table. I would suggest that a good high-level direction for us here is to rely on vacuum to do garbage collection in parts of the table that are updated infrequently, and to rely more heavily on more bottom-up techniques. Now, we already have some of these. I think we can add more and more. And I have plans to add a new mechanism like this to Postgres 14, which will be released next year. So there's no reason why you have to wait for a vacuum to come along. You can do things like, I mean, I mentioned retail index tuple deletion as one possibility, or as well, I mentioned it earlier, but it is one possible way of dealing with this. There's no reason why you can't delete index entries very quickly, which will solve most of the problems that you have with vacuum, where vacuum takes too long to get to the index entries. So vacuum is a sort of top-down mechanism, and there are advantages to having a top-down mechanism, but it's quite possible, and I think I've all but proven this already, to have bottom-up complementary garbage collection, which greatly ameliorates the downsides. I would also just mention, for the sake of people that maybe are thinking about this low-level stuff for the first time, that the design that we have is something that has a lot of advantages we don't tend to think of it that way because we see things as really discrete, but they're not. So the way that Postgres has a rich...
to fix things we run into. So
yeah, it's quite understandable, But sometimes it misses subtleties, like the whole Postgres ecosystem with indexing, all the rich indexing capabilities we have is, to a large degree, I think, a consequence of this design. So if you look at the history, if you look at the evolution of the design of the system, I think you see that there was originally an emphasis on extensibility and extensible indexing. That was the original priority, both when it was an academic project and later. And that tended to result in weaknesses in other areas that were, I would contend now, more accidents than inherent limitations. So what I'm thinking about doing now, and likely will do in Postgres 14, is to teach indexes to sort of fight back against bloat from non-hot updates in a very bottom-up fashion. So I've got a patch already that it's sort of, you could, I suppose, think of it as my response to the Uber blog post, which we all, I'm sure, remember from, what was it, 2016?
Remember, right? It was.
Yes. Oh. So what it does basically is, well, if you have non-hot updates, that is, if you have updates that affect maybe only one indexed column, but you have 7 indexes, it's currently necessary to create a whole new round of index tuples for each and every index, and not just the index that was logically modified by your update. And that is certainly a problem. But my proposed solution is to detect that situation within the index access method, and if and only if the page is about to split, then we opportunistically go to the heap, go to the table structure and check, oh, do I really need to split the page? Because I'm pretty sure these are duplicates that are garbage now. Okay, they are. And this is demonstrably very effective. It's almost 100% effective, at least if you are concerned about the size of the indexes. So what my testing is showing is, as long as you don't have a long-running transaction, the indexes stay the same size under almost all conditions. So if you're just measuring it based on the size of the indexes, it sort of mostly fixes the problem entirely. And that's kind of what I was getting at when I was saying, I don't think some of these problems are inherent properties of the vacuum design or the invariants that are imposed on us by the way versioning works. It's sort of, we have in block versioning. I think rather that it's just something that hasn't been sufficiently well optimized at this point. And we're going to get, I suspect I won't be the first person to do something like this in the next couple of years. I suspect that other people will do similar things without necessarily coordinating with me. So I would also point out that there's technology in SQL Server 2019 called ADR, Accelerated Database Recovery. Sometimes it's called instantaneous recovery. And this is essentially a way of making SQL Server behave more like Postgres. And this even includes adding vacuum. So they added vacuum to, at least it's when you turn the feature on, which you may not want to SQL Server, and it, I believe, has all of the same advantages and disadvantages as our own. Like there's additional row overhead, which is documented. They have things like well, they have a vacuum cleaner, as I mentioned, and you might wonder, well, why would they do that? Does that really make sense? Why? Excellent question. The reason why is it turns out that because vacuum doesn't require vacuum makes, or not vacuum again, the broader design that encompasses vacuum makes rollback instant. We all think of rollback as occurring instantaneously. In the SQL Server world, that isn't true. So what they found when they were running SQL Server in Azure was that some customers sometimes, in extreme cases, could have a database crash, and then the database would be in recovery for 12 hours because they had one long-running transaction and they had retained redo for that, and they had to, because of the way SQL Server works, they had to basically have recovery undo that work before anyone could really read the table.
Interesting.
So whereas if you don't, if everything is, if rollback is logical, then yeah, you've bloated the table, but recovery doesn't have to do like a log analysis, and it doesn't have to have an undo phase, and that could that design is in many ways more robust. Of course, we also know it's other ways it's less robust. My point is, I see these things not as, I see these things as fundamentally as trade-offs, and these are trade-offs that are, I believe, a little better understood now than they were a few years ago. I'm trying to maybe say provocative things about it in case it helps someone else to do similar work in another area, because, like I said, I think that's entirely possible.
This is very interesting. I always thought that like the MVCC model Postgres chose and implements, it's like pessimistic because indeed rollback is fast, but and we put data to new place, so we are supposing that we need, like if in the case of rollback it's very fast. In the case of but we need to clean old old space later. So why, like another approach when we put new data to the same place and move old data somewhere else is like a more optimistic approach, saying that rollback happens less often than commit happens, right? So, but you're talking about recovery, so this gives another perspective, and it's really interesting.
So I think that it's not so much, people always say what you just said, oh, why would you optimize for clearly the uncommon case of rollback? Of course, that's true. That seems dubious. And I don't think that's why it works that way. I think the reason it works that way is, like I said earlier, extensibility and flexibility. So, but I also think it's true.
Time travel was like, how's it called? Initially, it was because there was
idea. That too, yeah, that too. Yeah. So if you go back to so systems based on two-phase locking, like Oracle, or really any of the large enterprise or the VMSs, seem to all function on basis of. I mean, I say Oracle is based on two-phase locking, which people will perhaps wonder, well, how could that be? It's MVCC. It is, but they kind of started with two-phase locking and worked backwards from there, which is a very traditional design.
But MVCC is two-phase locking as well. It's just multi-version of two-phase locking.
Yes. So with Oracle, say, everything seems to work on the basis of having page-level versioning, and so it has many of the advantages of MVCC and other advantages that our design doesn't have, but it also has many of the disadvantages of two-phase locking, which we don't think of because we're looking at it from the other angle. The locking characteristics in bitmap indexes for Oracle are completely different to the locking characteristics for regular btrees, even though a bitmap index is fundamentally a btree that's good at storing duplicates. They kind of have to do this because they always need a consistent version of each page. So you just use bitmap indexes in Oracle for data warehousing. That's what they're for. So people don't use them with OLTP at all, because if they do, what they find very quickly is that even with very light amounts of concurrency, they'll deadlock immediately, because they have to have a consistent version of the page. So they cannot have multiple rows at any level of the authoritative relation structure. So a heap page has to more or less to the logical state of the table. Same with an index page. That seems to be how it works. So this is nothing to, you may have noticed that this doesn't mean that we can't do some of the things that they're doing because they have to make sense from a physics point of view. There's nothing to say that Postgres, for example, couldn't basically still work the same way, but then if necessary could store old things in a subsidiary structure. That's perfectly compatible with the design. It's not actually true that we can't do that, because there's no rule that says that. So I like to make that point because it might be provocative in a useful way. I mean, I know that there are other efforts underway. zheap is one. zheap, I believe, I don't know very much about it. I believe it doesn't, it's much closer to the existing heap than anything else. It doesn't try to do what Oracle does. So there are all kinds of opportunities there. I think it's a failure of imagination to say that we can't do some of these things that are helpful.
So if we're speaking of programming languages, the old discussion between software developers. So basically you have two opportunities. Either you have a garbage collection, or you have fully manual control on memory and need to do things like in C. But it looks like from things you are saying that in database world, there is no such strict dichotomy. Like you can use MVCC with like sort of garbage collection or vacuuming. You can use that with different approaches like Oracle use undo segments per each session, etc. But you can combine this as well.
You can can turn off auto vacuum and do it manually.
Or some sort of micro auto vacuum or pre auto vacuum or both things together.
A lot of these things we already do. I could go into details on that. I won't. But you know, some of the advantages to Oracle are not in fact because of they're not having vacuum exactly. It's very understandable that people think that, but I don't think that's exactly true. And the difference, though small, I believe is very important. And it's kind of weird that I was the first person that seemed to notice that, but here we are.
Sorry for interrupting. So the big idea is that a lot of room for improvements of btree indexes still exists.
Yes, I think so. And what I'm working on at the moment is basically a reliable way of removing garbage in indexes that has essentially the same good properties, but far fewer of the negative properties. I kind of like to think of my work as not so much adding things that are useful as subtracting things that are harmful.
I see.
In indexing, I think that's a good mental model to have. It's not the only one, it's not the correct one, but I think it's a very useful one sometimes.
And like recent releases 12 and 13 particularly, they show these like good improvements. And how do you like for end user, how we can like, is it possible to say like we have 2x improvements and 12, 3x and 13, some numbers? Is it possible to have some how to form expectations for users, or we need to say please test on your particular case all the time?
Well, we always need to say that, I guess, but I mean, I think I saw. So what I was saying around Postgres 12 was with TPC-C, the indexes were approximately 40% smaller, which I think amounted to an increase in throughput of about 10%. I don't really remember. And I mean, it would vary based on things like the size that you'd made the database and stuff like that, the number of connections. What I often like to do is to focus on things that are relatively easy to measure, not because that's necessarily a good thing to do, but because it's so much harder to explain throughput because it's conditioned on so many things. So I think with 12, it's more something that you see looking at the entirety of your application. If you look at, you'll probably notice that your indexes are less bloated, or that they don't grow to a certain size in the worst case. And this is especially likely to be true with 13. The deduplication stuff is particularly effective at, like, if it's for whatever reason you happen to get an extremely bloated index, the deduplication stuff is very effective at making that worst case more tolerable. So that's kind of what I don't actually remember the kind of shiny go fast numbers. I mean, they exist, but I think EDB did something about, well, second quadrant EDB did something about TPC-C in Postgres 13, which they showed at 250 clients had I believe a 20% increase from 12 to 13. I'm not sure that that's due to the Postgres, the duplication work, but I think it is probably due to that.
Okay, so basically there's no good magic number. Everyone should test.
Yeah. Right.
And see.
I think so. Yeah. What I would say is, if you feel that you have a big problem with index bloat today, then definitely try it before too long. Like, there's no question that if you have a problem with it today, if you're not happy today, you're much more likely to be happy by upgrading, especially to 13. So that's maybe a better, if you're already happy with what you have, it's probably going to make less difference. But it's really hard to know it's really hard to know how many people are in each camp, you know. So I can't really say.
And not happy.
It depends on your pattern on how you use it. For example, maybe if you have extreme amount of indexes, etc., your developers would be happy. If you're not, probably your admins would be still happy because they can like maintain small amount of indexes. That's different story, but still.
Yep.
So not happy feels like you need to repack or reindex very often, right?
That would be one. Yeah. So I think you'll know about this, Nikolai. I think GitLab had a pretty good analysis of index bloat on Postgres 11. Yeah, which I found really interesting, actually. I'm kind of hoping that they'll be able to show something interesting with what we've done with Postgres 12 and especially Postgres 13. I mean, if you have any kind of low cardinality data to begin with, which you most certainly do, like if you've got more than 5 or 10 distinct logical rows for each value in the index, you're definitely going to see a big improvement. So they'll definitely see that. But the question is it big, or is it like something that makes a huge difference? Is it big on paper, or is it big in real life? These are two different questions, I guess.
Right, and that analysis was done for 9.6. It was some time ago, and right now they're migrated to 11. So it's still there's still
need to wait a couple of years.
That's fine. I noticed it because, I mean, this is the kind of thing that is hard to come by. There are very few people that are publishing this kind of information. So yeah, whenever I become aware of it, I like to look into it, which I did there.
Right. I will put all the links to our document and to comments here to the description of this video. So it's all everything like very interesting, because to have better, more complex indexes, less bloated, you don't need to repack or index so often. It's very good. It's very good, and it makes Postgres stronger, right? But what about, right? So I hope we will see more real life numbers from production for Postgres 13 quite soon. Of course, few projects migrated. I saw like only a couple of mentioning that we already migrated because it's too young. But speaking of Postgres 14 and your new thing, which currently under development, it's from the subject of this discussion, deleting older versions in unique indexes to avoid page splits. It's only about unique indexes, or you have idea to extend it?
It was only unique indexes in June. Then I decided to extend it to all. I thought of a way of doing it that seemed clever. The cleverness is basically to exploit an asymmetry, which is something that I often try to do, especially with indexing, where you're about to split the page, and splitting a page is very expensive. So you can justify doing a relatively large amount of work if the payoff is that doesn't happen. So there is this sort of massive imbalance between the certain downside of not doing it, and there's another imbalance in that we can, if we're looking at the visibility information in the table at that point, we only usually have to access 1 or 2 heap pages to determine that it's not going to work. Whereas if it does work, it's great. So we have a very small downside, which we understand. It's not hard to understand the downside, right? That could be wasted effort, but the upside is uncertain, but potentially huge. So that's kind of another asymmetry there as well. So it's kind of a prominent example of greatly improving things within the context of our existing design, which I don't think is so much it's not that vacuum itself is a problem. I think we just haven't optimized many of these things quite as well as we could, and here we are.
It will be interesting to see if, like, because some people thought that we have very soon we will switch to different storage, no more vacuum. But what you're talking about today, it sounds very different, and maybe we will have still we'll have the same infrastructure, but much more optimized, and everyone will be will be happier, right? So,
right. So I'll give you another example, which I think is a little like what I envision in some very general way. So that there's in SQL Server, there's something called Hekaton, which is an in-memory system, which is all MVCC based. And Hekaton has something called dusty corners. And dusty corners means, because most of the garbage collection is happening opportunistically, and that's doing most of the work. But then what if queries or something don't visit parts of the table after a long time? Well, then you've got dusty corners. So you have to go and specifically reach for those dusty corners. But so there is a vacuum, but it's only for dusty corners. It's not for the bulk of and I think that is the kind of thing I would like to see Postgres doing. So we don't change the fundamental invariants. We don't change. So vacuum theoretically still works exactly the same way, except it doesn't because it's doing way less work. I think that's possible with enough effort. I could be wrong, but then, I mean, it doesn't really matter because I feel like that whatever particular understanding of it prevails will be the best one. So that's my theory on it, though.
So basically, now Wacom is still too general, too universal approach. So Wacom works just on a very top level, tries to do without any specific things to deal with indexes, with heap, etc. And your idea is that we need some specific, not just optimizations, but like effective access methods, effective balancing methods for specific for indexes, specific for heap, specific for different indexes, probably. Right.
So I would say that non-hot updates, which are really what I'm concerned about with this most recent work, they have what people sometimes call negative externalities. So sort of like a corporation that doesn't have to pay for polluting and therefore has every incentive to pollute because it's imposing a cost on everyone else and not paying a cost itself. That's a problem because, of course, it's going to just keep doing it. If you impose the cost on the people doing the damage, then their behavior will tend to improve markedly. Or at the very least, they just can't do it anymore because it's not possible for them to sustain. So what I'm doing with the indexing stuff is I'm making non-updates responsible for the mess they're making. And if you can fix these problems very, very early, sometimes that's much better. Prevention is always better than cure. So we don't have to stop them from, it doesn't have to be immediately after the transaction commits. It can be maybe when we're splitting the page, for example. That's when, the situation arises where, well, we need to make a final decision here. Are we going to split the page because of this, all of these same versions, or are we going to do something else? We're going to delete the stuff. What can we do? I guess it's important to not make any to have these assumptions questioned every once in a while, I guess.
We have a question in chat. Question about possible btree improvements. Do you think merging partly full pages on deletion could be beneficial? Some workloads suffer because of that. So just a few of those, though.
That's a good question. A lot of people ask that question. Well, relatively.
If we split, why we don't join back, right?
I can give a very specific answer to this question. I personally believe that counterintuitively, well, first of all, we're much better off preventing splits from occurring in the first place, right? So if nothing else, I would do that first. No one could argue with that. But even then, it turns out that that's less valuable than you would think, for reasons that are. So there is a very detailed mathematical analysis of this question. It was papers published in the early 90s by, I think it was Shasha, who was out of the NYU University. I can give you the name of the paper. I have it's one of my, hang on a second, I'll find this.
And we will put that into comments later.
Yeah, it turns out actually that it sounds kind of like, oh, you're just being sloppy, you're not merging together these two pages when you could, but in reality, the way it tends to work is there's very little difference between, if you model it in a probabilistic way, there's very little actual space savings, because in general the rule is it tends to be either that the index is constantly growing, and if it doesn't grow, then in a localized fashion, then it doesn't make much difference until it's completely empty anyway. So if you, I'm probably not doing this justice now, but sorry, hang on.
Yeah,
I should.
So,
I'll get to it later.
Yeah, I will put it to Docker right after our call.
It's a good question. It's a good question. Like, that is a surprising result. I was surprised by that myself, but ultimately I found the argument quite convincing. So
so there is analysis showing that maybe it's not that beneficial, right?
Yeah, actually, here's another link you could use, which is actually easier to follow. Sorry. So it's an old Dr. Dobbs article,
okay.
which is written by the same people. Free at empty is better than merge at half. I think that's the name of. So this is Dennis Shasha, who's one of the people that influenced the original design of
right.
implementation.
I've added it to our document.
Okay.
But also, like, maybe not really related question, but indexes. I wanted to ask it as well. Sure. Indexes by default, they have fill factor 90. So 90% of pages are filled by default. So we have some room to very actively active inserts or like to have some room. But heap pages are by default fill factor is 100%. Why so? And do you recommend to looking at it at all, to trying to adjust for particular workload, to change fill factor for indexes? Does it make sense at all?
I would say it would make more sense to reduce the fill factor on a table where you have a lot of updates. My observation is that can be quite helpful if you have lots of intense updates. Fill factor in index is only something that is effective when you initially create the index, where it fills pages, say 90% full by default, and when you have rightmost page splits. So that seems less useful to tune, because I mean, you either have lots of rightmost page splits because it's a timestamp column or something, or you don't, and that generally just works, or it doesn't happen at all, so that's fine. It doesn't even come up. So I think I don't know that heap fill factor, its default, is optimal for many workloads. I wonder though, I mean, in the current environment, I imagine a lot of people just don't have that many updates because they can afford, at least relative to 30 years ago, say, to store most or all their data without needing to necessarily update it all that regularly. So there maybe is an argument to be made for, well, let's optimize the space utilization of inserts, and that maybe is why the default is 100 now, but I'm not sure. So anyway, I would definitely do heap before index. Yeah.
I see. So, okay, no more questions about indexes, and we spent already more than 1 hour. But I do want to talk a little bit about prevention, like how to say, control over
data corruption.
Yes, data corruption, especially in indexes. We can deal with a lot of various corruption on various levels. But speaking of btree indexes particularly, you contributed amcheck module, and what can you say about it, and how people should use it? For example, the question where we should run it, on all production nodes, including replicas, or is it okay to run it on a machine where we, for example, verify backups regularly, we restore from backup and run amcheck there, or we do need to run it on production nodes?
Well, hopefully you can do that without too much pain anyway, at which point it doesn't really matter. People often ask that question when amcheck comes up. I believe if you look at the database, other certain database systems have roughly equivalent utilities, and I believe one of them said every week. I personally also think that that's completely arbitrary and a number someone made up sometime, because when you're talking about corruption, when you're thinking about corruption, I think you're thinking about things that are by definition exceptional, right? If your data is getting corrupt in any particular predictable way, clearly something has gone very wrong. Presumably that's not what your problem is. Presumably you are concerned about the exceptional. And if you look at how many things can go wrong, it is an enormous number. Modern hardware and software stacks are so complicated. You have a hidden universe of complexity in every SSD now. Very complicated firmware in every SSD. You have file system problems sometimes. You have all kinds of issues with backups being performed incorrectly and things of that nature. So it's impossible. Like it's by definition impossible to know where to look for it. So I would say it's more like
exactly the reason why people ask this, because
yep.
people are afraid of hitting at some point corruption where they do not know about it. Right.
So I think that the 1 week thing, I'll just go with that number. It's totally arbitrary, but I'll just say that. Or another thing you could say is if you can afford to do it every day, or do it every time you restore from backup would be another one.
If we restore from backup, run it there, is it enough? Or we should go to primary database and run it there as well?
Who could say? I mean, I think it's good to run it on a secondary because it's sometimes easier.
Right.
It's not like I mean, you can make up a rule and maybe that's fine. But that's sort of what you're doing because it's just intellectually impossible to say what's going to happen. If you knew that, then it wouldn't happen and you wouldn't have the problem. I mean, theoretically speaking, amcheck is useless because it's verifying things don't happen that are not supposed to happen theoretically. I mean, in theory, there's no difference between theory and practice. In practice, there is. And that's not really. That sounds like I'm being glib. I'm really not. That's the reality.
Okay. So as I know, there are basically there are two basic functions in amcheck, and one of them has parent word in the name, right?
Yes.
And it's more like detailed analysis, and it also checks relationship between leaf nodes, right? And this is actually what I would like to have, of course, right? And prior to what, Postgres 14 or 13. So do we have it right now? I think no. So as I remember, this function, if you run it, it will block updates, inserts, and so on, right? So modifying. And recently, as I know, Andrei Borodin submitted patch, and you pushed it, right? So we will have a better version in 14. So next.
Yep, that's right. So that affected the one that I believe most people use, which is not the parent one. It's BT index check.
Right. It brings
not BT index parent check. So that one is the one that you probably want to use anyway. And Andrei, as you say, enhanced it so that it had its extra check, which he found was very valuable in the environment he was using it in.
So we don't need parent. We do not need to run this parent function, right? Because
right, and the parent function is really there when you know that you have terrible problems, and you, which is almost never, I assume.
It's more like ad hoc tool, right? So parent is
well,
more...
it's as thorough as possible. There's practically nothing that it won't detect, at least now. Actually, Alexander Kortkov wrote a really excellent patch for it that went into Postgres 13 that isn't in the release notes, that made it even better, which I was really happy about, because it was amazing that someone had taken something I'd done from the start and then made it like a lot better. It was actually very gratifying.
Right.
Anyway, it's something you just probably don't want to use until you know you have terrible problems, at which point, you know, having every possible check becomes logical. The main reason you don't want to use it most of the time is because of the locking. It basically blocks, it doesn't block reads, but it blocks writes. Whereas the one that you do want to use, bt index check, doesn't block reads or writes. It doesn't even block vacuum. So that's the one you want to use almost always. Also, that will run on a standby, whereas the parent variant won't. So I just wouldn't use the parent variant unless you know you've got a terrible problem already, which hopefully never happens.
And even so, we could, if it's possible in our infrastructure, we could clone primary and run it separately, not disturbing.
Yeah, that's a great thing to do. If you have physical backups, which you probably should, you can easily restore it and test that, and not have it even be a replica. That could be almost as effective and much less disruptive. So that's a good idea as well. Yeah.
This is what I do actually. So not everywhere, but we just recently started to think about it. Like, let's add this kind of check.
That makes you far ahead of many users.
Right. I think the problem with amcheck now is that it's too bottom up. It's not. It needs to be more top down. It needs to be something where there kind of is a nominal answer, at least, to how often do you run it, blah blah blah. Or
Best
you could just say, it's too low level. It's too low level at the moment.
Lack of guides or something.
Yeah. Sorry, go on.
Yeah, go on.
That's a problem that we recognize. And again, someone else is doing a heap module that will be part of amcheck. Yeah, heap check, which is not that closely related, but it's going to be part of the same module. And I believe there's a good chance that as part of that effort, we'll have something that's more like, you know, it's not crazy esoteric stuff. It's like, oh, is my database corrupt? Give me a moderately thorough analysis of that, which is what you tend to see in SQL Server. You want both. You need both really, but it is unfortunate that we don't have that part of it yet.
Should repeat the way of pageinspect statements from some marginal extension to the thing which
to standard
prerequisite to use Postgres.
Everyone uses it, right? So speaking of amcheck, there is opportunity to contribute in terms of writing good articles, user guides, and test it and provide how to deal with it better. So I mean, addressing this question to community, if someone wants to help, there is good opportunity here, right? Good, great, and maybe last question about corruption. If amcheck showed some corruption, what to do?
I have to give another
small question.
I have to give another existential horror answer, which is like, it's a Lovecraftian horror show. It's like, I don't know, maybe it's terrible, maybe it's no big deal. Right. It's usually no big deal, but what is true on average is not relevant to what's happening to you. It just isn't. And people hate when I say that. They hate when I say that, but I'm still going to say it because it's still true. That's the reality. You have to know what happened. You have to do root cause analysis, which in general is hard. It might be something as simple as a change in the operating system correlations that you haven't accounted for with a physical backup. That could happen, for example. It might be a problem with the way that your backups are taken. If you, for whatever reason, aren't using a nice tool to do that for you, that becomes more likely. That's something we've seen before. But I can imagine 1,000 scenarios that are, yeah, it really is.
Right.
Yeah, yeah.
It's a proper point to call for a professional.
I think so. Yes, yes. You can. There's many very good support companies. I happen to work for one of them. There are others too, including in your region. So you can hire them, or just post on the mailing list. I do see more people reporting that kind of thing.
Right,
it's all over. It's all over the map.
Without root cause analysis, if you just rebuild index, it may very easily return, and it's not like it's blind move, right? So you need to understand it.
But the thing about corruption is, like, say you have a large environment where you run thousands and thousands of databases, and then you figure, not unreasonably, oh, I know that in general database corruption is rare, and then you find database corruption in one of your databases. Now all bets are off. For all you know, it could be all of your databases are corrupt, or maybe it's just that one. Like, whatever may be true in general kind of works maybe a little bit before then, but at that point, who knows? Because it's an unlikely event that's happened. So what was true before is irrelevant now, because you're, one of the special ones that has an unlikely event. And now you get to learn a lesson about how not to do that. That's kind of sort of how it might work if you are in an environment where you have a lot of databases. You're a larger company, say, where you have a certain consistency to how you're using the system, and you kind of have to treat it like something that you have to learn some kind of lesson and apply that lesson and eliminate the problems in a kind of
right. And like if we trying to understand what is happening, I assume pageinspect standard module can be very useful, and you also developed graphical interface pageinspect. I assume it also can be useful. Pageinspect, right? It
can. Because we're now in the realm of extreme events. If we're dealing with corruption, or maybe we're not. Maybe we can figure it out pretty quickly because it's something that is relatively common, like the collation issue I mentioned. But if it isn't something like that, then you do have a difficult task to figure out what it is. You have to isolate the problem. You can isolate problems in many different ways. Like it's probably going to be specific to your situation. Like, what changed? Did something change? Obvious things like that are usually what you think about.
And speaking of pageinspect, we mentioned it in our Russian streams also, and I complained that it was difficult. I used it a couple of years ago to just to see alignment. How's it called? Alignment.
Overhead.
No. Inside page. Forgot the word. Alignment when you have zeros. When you have int 4, int 8, you have 4 zeros, right?
Yeah,
padding. Padding,
yes.
Yeah.
I knew what you meant immediately, but yeah.
So,
I couldn't think of padding.
Right, and so recently we made it possible to build it on fresh Ubuntu, on modern Ubuntu very easily. So now it works. And Denis Smirnov, who watched our Russian stream, he helped me to make it working on macOS, so you even can use it on macOS. Cool. And if people are interested, go and check it out. It's interesting to watch how it works and see hex editor and see pages, and including in indexes. And as I know, you added support not only for btree but also for Gene, for other indexes, right?
All index types that are shipped with, unless you can contrib Bloom, but other than that, so Brin, Gin, Gist, SP Gist. Actually, I'm really glad that you like it so much, because it seems to be something that a lot of people haven't said anything about, even though I put a lot of work into it. I thought of it as a kind of an investment, an educational tool for people.
Right.
It's also something that I work on to kind of, it's nice sometimes working on Postgres to step back from that and work on something that's kind of my thing only, just as an exercise. So for me, that's pgedit.
Just not to submit it to hackers.
Yes, it's kind of a slightly crazy idea that turns out surprisingly to work well. So I'm really glad that you like it, actually.
But you still have a disclaimer that do not if you run it, you should be prepared to have data corruption as well, because it may produce if you saved something. And actually,
sorry. I was just going to say.
I wanted to mention that Denise, who helped me with macOS setup, he also mentioned that he used it to analyze some corruption of PG class or some kind of system catalogs, and I'm not sure if it helped directly in his case, but he used it to understand what is happening under the hood. So it's the case when corruption was investigated using this tool as well. But again, you need to copy first, right? You need to back up your PG data first.
Yes. I mean, I guess you have to put the warning there because, well, that's the culture, isn't it? But like, it is what it appears to be. If you break it, you get to keep both halves, obviously.
Right. Cool. Any graphical things attract a lot of people, even those who deal mostly with console, still to see something graphical.
There are some things that I mostly work with the command line myself, but there are a few things that are better with I mean, it just is intrinsically a visual process, in my opinion. So, and you can convey a lot more. You've got a very dense structure, and you can convey a lot more information intuitively by using color and things like that. So I actually put a lot of thought into that stuff, which I think you maybe are aware of.
Yeah, I'm not sure about everything, but I'm going to experiment with it definitely more. Thank you for this tool and for all contributions.
Oh, no problem.
Yeah, no problem. It's a lot of interesting stuff. So we like I especially want to say, like yesterday and before in Twitter, I have a discussion about submitting patches to hackers, and I must admit I'm on pause mode completely myself, because I see that it's like a huge barrier. In my previous experience, I had cases when you need a lot of energy to stay on your point and to prove it's better. So right now I'm not doing it at all. So again, I like admire a lot people who continue doing it, and huge work to develop Postgres further. So it's cool. Okay.
Thank you. I do appreciate it. I'm saying I do appreciate that. People don't actually say that stuff very often, so it is nice to hear.
I recently have heard a lot of feedback that those features are actually extremely welcomed in community of users. First of all, that's we can see that in our chat as well.
Great.
Okay. So I think no more questions. I wish you continue working in this direction and bring more optimizations we all benefit from. So it's very cool, and I hope people will join and either in helping with development or contributing in the form of feedback, testing, and like some articles, blog posts, and so on. And okay, I think that's it. Thank you so much. I hope
that was very interesting talk. Actually,
for me,
a lot
definitely.
Of technical details.
Yeah, for me, definitely. I hope. Okay, sorry.
I'm happy to do it. And I would recommend anyone else thinking about doing this to do it as well. It's very positive. Thanks.
Oh, I have a list of people which I ask you to influence about this.
Okay.
Good.
All right.
All right. So it was interesting, at least to me. I hope it was interesting to people who watched it and will continue watching in YouTube. Please subscribe and press like button. It will help to reach a wider audience and build good channel. And okay, see you later and talk to you later.
Bye-bye.
Maybe in Twitter.